Today on the Perception in Action podcast, can mental imagery be used in a manner that is consistent with the ecological approach, allowing for self-organization and the development of functional movement variability? So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Now on to the show. Although physical practice is viewed as the gold standard for skill acquisition, substantial evidence supports the use of mental imagery to enhance skill development in the literature. It can also be particularly effective for athletes recovering from injury that can't do full physical practice. Mental imagery is a topic I've addressed a few times previously. Check out episodes 337 and 347 for more information. Mental imagery is often referred to by many terms, including mental practice, motor imagery training, imagery, or visualization. It can be defined as, quote, in the context of sport, it may be considered as a creation and recreation of an experience generated from memorial information involving quasi-perceptual and quasi-affective characteristics that is under the volitional control of the imager, and which may occur in the absence of the real stimulus antecedents normally associated with the actual experience. Morris, 2005. Previous research indicates that mental imagery and physical executed actions share the same neurophysiological mechanisms and draw on similar mental representational system involved in generating physical movements. This is often referred to as functional equivalence. These shared mechanisms are often referred to in explaining how mental imagery effectively produces similar training-related adaptations as physical practice. Presently, mental imagery interventions often approach skill development as a linear process in which expertise is acquired from task repetition. The aim is to reduce variability through repetitive practice to create accurate and consistent actions. Considered this way, practitioners impose a predetermined movement model that is viewed as optimal, and learning is characterized as a process of transferring the optimal movement to the learner until they can accurately replicate the prescribed model. This approach is highlighted in mental imagery interventions by implementing instructions that expert performers, coaches, or researchers often generate to provide a technical description of what is considered an optimal technique. This approach is prescriptive and repetitive, which places the coach practitioner at the center, with great importance on specialist technical knowledge. What I want to look at today is an article by Lindsay and colleagues which addresses the question, can we use imagery in a way that is more consistent with the ecological approach and nonlinear pedagogy? The design principles of nonlinear pedagogy, which I reviewed back in episode 377, provide practical guidelines on how practitioners could help learners develop attributes such as adaptability using motor imagery. For example, rather than providing a specific movement form, motor imagery content could incorporate details of nets that differ in height across tennis practice, in other words, manipulate task constraints, and tell learners to try and hit the ball toward a target. This would require learners to adapt movements continuously to the different net heights to achieve performance outcomes. Further, instead of having learners use mental imagery to hit a target, details could describe an actual opponent and the noise of a crowd. Such details would capture the nonlinear pedagogy design principle of representativeness, an important consideration for practitioners when assessing whether practice environments actually represent the demands of competitive performance. From a nonlinear pedagogy perspective, the key principles of representative learning and information movement coupling suggest that practice should simulate critical elements of the performance context. For example, defensive pressure or the presence of other team members, to help learners become better attuned to relevant information to establish information movement coupling that supports successful performance. Applied to motor imagery, this could entail motor imagery content that refers to important aspects of the performance environment, such as the presence of defenders in an attacking situation during soccer. Thus, the key point highlighted here is that motor imagery practice can be designed to be executed in alternative ways. Specifically, motor imagery practice that can be supported by nonlinear pedagogy principles to facilitate individualized skill development. To appropriately apply a nonlinear pedagogy in practice, it is important to follow the key design principles that support a nonlinear pedagogy approach, such as manipulation of constraints, Practitioners should aim to guide learners to opportunities for actions to allow for exploration and exploitation of functional movement solutions through careful manipulation of task constraints. Number 2, encourage exploratory behavior. Learning design should leverage functional movement variability to apply exploratory behavior to facilitate the development of individualized movement solutions. Number 3, information movement coupling. Task simplification and learning design can be implemented and should support the strengthening of information movement coupling. Number 4, representative design. Task design should aim to simulate critical aspects of the performance environment to provide the learner with key information to appropriately regulate their movements. And finally, number 5, attentional focus. Instructions should be developed to focus on movement outcomes, an external focus, rather than specific body positions, and an internal focus, as this facilitates self-organizing processes. Given that motor imagery training occurs within a simulated environment, practitioners and learners can manipulate task constraints through scripts delivered during mental imagery practice. For example, when looking to develop tennis return shots, scripts may manipulate the height of the net to describe target areas to hit the ball that change as practice progresses. Aligning with the physical component, practitioners may also set up the actual constraint in the area that mental imagery training takes place to provide a concrete representation of its dimensions. Practically speaking, this may look something like the following. Quote, as you set up to receive serve, take note of the height of the net. It is higher than usual. As the server approaches you and you set up for your return shot, take note of where your opponent is standing. Try and hit the ball up and over the net to the space outside of your opponent's reach. End quote. In this way, the aim of the script is to include information to provide a performance context for the learner to explore, rather than describing a specific movement pattern to reproduce. From a nonlinear pedagogy approach, first-person perspective may provide a more authentic representation of relevant affordances in the performance environment as compared to a third-person perspective, allowing learners to become better attuned to critical information to strengthen information movement couplings. In a nonlinear pedagogy approach, instructions tend to be more exploratory in nature, aiming to guide the learner toward overall movement outcomes rather than prescribing a specific movement form. Movement outcome-focused instruction can facilitate inherent self-organization processes to guide movement patterns, encouraging the development of more individualized movement solutions. The authors go on to suggest that applied to motor imagery, this could be achieved using analogy-based instructions. For example, imagery scripts may include statements like the following. Imagine striking the ball in the shape of a rainbow, or, quote, shoot the ball like you're reaching into a cookie jar on the shelf. Captured this way, motor imagery practitioners may want to design scripts that detail movement outcomes rather than the prescription of specific movement form. This approach may provide learners with the freedom to explore and exploit individually appropriate actions and move away from optimal movements that may be mismatched to their abilities, skills, and physiological makeup. This paper also includes a very nice study comparing the effectiveness of linear and nonlinear mental imagery. This study exactly mirrors the study I talked about back in episode 408, where the same authors compared nonlinear and linear physical practice for the task of learning to power clean in weightlifting. The present study aimed to explore the application of a nonlinear pedagogy-informed mental imagery intervention in relation to a more traditional linear style of mental imagery intervention for beginners learning a movement form-based skill, the weightlifting skill known as the power clean. It was hypothesized that 1, a linear style practice would develop a higher frequency of optimal movement patterns. 2, modification of task constraints in the nonlinear pedagogy condition would help facilitate exploratory behavior and guide learners towards performance-relevant solutions. And 3, both conditions would demonstrate the same levels of performance accuracy as measured by the forward and backward barbell movement during the power clean. Here are the details of the study. 14 participants were split evenly into 2 groups. The present study comprised a pre-intervention technique assessment, followed by a 4-week intervention, 8 mental imagery sessions, each lasting 30 minutes, and then a post-intervention technique assessment, approximately 24 hours after the intervention. Following the pre-intervention technique assessment, the participants completed 8 mental imagery practice sessions, approximately 30 minutes, across a 4-week intervention period, to learn the power clean, using either a nonlinear pedagogy or a linear pedagogy approach. When in the start position of the movement, participants will listen to either a linear or nonlinear constructed audio recorded script that guided them through 3 to 5 trials of mental imagery. Both scripts were designed on the understanding that when performing the power clean movement, there's a heavy reliance on proprioceptive sensory information to regulate movement posture and control, as individuals performing these movements need to approximate their body position spatially by feeling the movement as opposed to seeing themselves perform it. Therefore, kinesthetic-focused mental imagery was the primary form of practice in the present study. For the nonlinear pedagogy condition, scripts were analogy-based, that is, focused on movement outcome to encourage self-organization processes and limit conscious movement control, aligning with the key nonlinear pedagogy principles of practice design. This included mental imagery instructions such as try and flick the bottom of your shirt as you pull the bar upwards, and explode upwards like you're jumping straight up. Manipulations of constraints are informed by principles of nonlinear pedagogy, such as task constraints, aimed to encourage exploration of individualized movement solutions. The manipulation of task constraints in the nonlinear pedagogy mental imagery scripts included chalk on the barbell and poles in front of the barbell. Participants were blinded to the true purpose of each constraint and were only told either not to hit the poles in front of them or try and leave a chalk mark on the thighs with the barbell. These constraints were also physically present during the mental imagery practice. Conversely, the linear pedagogy intervention was designed on the understanding that during skill acquisition, learners should be directed toward an optimal technique, and this is achieved through repetitive practice. Therefore, linear pedagogy scripts involve details of what is considered an optimal power clean technique. For example, keeping the bar close to the body on the lift, and were movement-oriented, aiming to have learners adopt a very specific movement form and leave little opportunity to explore alternate techniques. The linear pedagogy condition received prescriptive mental imagery scripts according to different phases of the lift that were heavily technique-focused. For example, during the second pull phase, quote, as your lower body extends, forcing you to be right up on your toes, and on the turnover of the barbell onto the shoulders, quote, bend your elbows and pull your body under the bar. What was found in the study? As predicted, there was more occasions of the optimal technique following the linear pedagogy approach. Overall, the results very closely mirrored that of the physical practice study I mentioned earlier, as there were no major differences between the linear and nonlinear pedagogy groups in terms of performance or the amount of exploration of solution space. Similar quantities of exploration were observed in both conditions, suggesting that prescription of a specific movement form may not necessarily ensure adoption of a particular technique, as learners may inherently explore for more movement patterns that match individual capabilities, skills, and experience. Equivalent improvements in performance accuracy and the adoption of a suboptimal techniques by both conditions suggest that the optimal technique does not ensure improved performance. One limitation I see in this study is they didn't really change the constraints during the actual tests and evaluation of techniques before and after. So there's not really a lot of incentive to employ different movement solutions. For example, it would have been interesting to compare the two groups in a condition where they used a heavier bar or in a condition where they're pre-fatigued before they lift. Regarding the quantity of exploration, no significant differences were observed between linear and nonlinear pedagogy, suggesting that the constraints incorporated into the mental imagery scripts were not a precondition for exploration. One potential explanation is that the exploratory behavior in the linear pedagogy condition demonstrates participants attempting to follow the prescribed movements, that these may have not been individualized to their own constraints, for example, the limb length and body weight. Exploration in the linear pedagogy condition might be defined more appropriately as a coordination instability, where participants are caught between inherent self-organizing processes and the need to conform to a specific movement pattern. Whereas practice was designed for nonlinear pedagogy participants to leverage functional variability by encouraging exploration and the emergence of individualized movement solutions. To sum up the study, the authors state, quote, the present study highlights the potential benefits of using a nonlinear pedagogy approach to mental imagery to encourage learners to explore movement solutions that align with a learner's capabilities without negatively impacting performance. It may be beneficial for mental imagery practitioners to consider designing practice that allows deviation from prescribed technical models to facilitate learners' inherent exploration of individualized task solutions. Future research should investigate further the efficacy of nonlinear pedagogy-informed mental imagery to develop further understanding of how to best apply these principles of skill acquisition in mental imagery practice. End quote. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter @ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including a monthly coaches meetup, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled. Gone through St. Louis.